Okay, so picking up with the GRE physics practice problems, this is set 3 in the series, 12 problems 38 through 49. For 38, in a non-relativistic one-dimensional collision, a particle of mass 16m collides with a particle of mass 3m. The particle of mass 3m is at rest. After the collision, the particles stuck together. What fraction of the initial kinetic energy no longer remains due to the collision? Okay, so what we would say, this is perfectly inelastic, non-relativistic collision. This is a bit of, these are basically, all 12 of these are like canonical type problems. Initial kinetic energy is only from the mass 16m. So we could say here, after sticking together, case of F over case of I, that's going to be m sub I over m sub 1, rather, over the sum of the two masses, m sub 1 plus m sub 2. 16m over 19m, that reduces to 16 over 19, but they want to know initial kinetic energy no longer remaining, so we 1 minus 16 over 19. Fraction not remaining would be 3/19. So answer would be 3/19. Moving to 39, 80 positive charges of magnitude Q around the circumference of a circle with radius R are arranged in a symmetric fashion. Find the magnitude of the electric field at the center of the circle if K equals 1/4 pi epsilon naught. Well, the charges here are arranged symmetrically around a circle. At the center, each charge's electric field is canceled by the charge opposite it. Thus, that electric field is going to be equal to 0. And by the way, I'm just going through these quickly just so you have a reference. You can practice the problems. Hopefully I don't misspeak or make any mistakes. 40, 900 volt potential difference is applied across a combination in which an 8 microfarad capacitor is connected in a series with a 24 microfarad capacitor. What is the total energy stored in the two capacitors? So if we have capacitors in a series, this 1 over C sub EQ, that's going to equal this 1 over 8 plus 1 over 24, the ones we're given. 3/24 plus 1/24 is 1/6. So C sub EQ is 6 mu F. Now the energy stored, here's the equation we need. U is 1/2 C sub EQ V squared. So U is going to be equal to 1/2 times 6 times 10 to the negative 6. Think about where that came from. You probably know. Times 900 squared. And we wind up with 2.43 joules. And that's what we wind up with number 40. So we can move along now to number 41. GRE jumps around a lot from all different topics, ranging from mechanics to quantum mechanics, thermodynamics, electricity and magnetism, etc., optics and waves. Okay, 41 here. We have psi is 1 over square root of 61 psi sub negative 2 plus 1 over square root of 33 psi sub 2 plus 1 over square root of 7 psi sub 3. Linear combination of 3 orthonormal eigenstates. If the operator of random g hat for this state, determine the expectation value of this g hat. They're using that as a notation. Okay, so think about what we have as our eigenvalues. So probabilities are going to be the numerator over denominator of these values squared. So 1 over square root of 61, 1 over 33, and 1 over 7. Those are our probabilities. So our expectation value is going to be the eigenvalues times the respective probabilities. So it's going to be negative 2 over 1 over 61 plus 2 over 1 over 33 plus 3 over 1 over 7. And this comes out to about, I think, 0.456. Okay, so 42, the absolute temperature of a black body is increased by a factor of 18. What is the consequence in the energy radiated per second per unit area in relation to this factor increase? Okay, so black body radiation follows Stefan Boltzmann law, in that E is proportional to T to the 4th. So if temperature increases by a factor of 18, we could say that T sub F is 18T. So this ratio E sub F over E sub I, that's going to be 18 raised to the fourth. So that's going to give you 104,976 E sub I. Okay, 43. Figure below shows a plot of the time-dependent force F sub x of t acting on a particle in motion along the x-axis. Determine the total impulse delivered to the particle. Okay, so the thing here is impulse equals the area under the force-time graph that we're given. There are points. The graph is triangular, so just find the area of that triangular region. 12s is the base, height is 8n. So J equals 1/2 12 times 8. So that's going to be 48 newtons per second. So J. All right. So newtons 44. Okay. Let's see here. Light from a laser falls on 44. Light from a laser falls on a pair of narrow slits. The slits are apart by 0.63 micrometer. On a screen that is distant, bright fringes 2.5 mm apart are witnessed. What will be the separation of the bright fringes if the frequency if the frequency of the laser is quadrupled? Okay, so let's see here. Double slit fringe spacing. So we're going to use the formula. Change in y is lambda L divided by D. Now, since the frequency is quadrupled, that F becomes 4F. And because lambda is C over F, the wavelength is 1/4 as large. So therefore, we could say the fringe spacing also becomes 1/4. So this is going to be the change in delta y sub f is going to be 2.5 over 4, and we get 0.625. Okay, 45. System consists of two blocks shown in the figure below. Here's the figure below. You have the y pressed against x. Not y on top of x, it's pressed against. So a system consists of two blocks shown in the figure below. A minimum horizontal force, F, is applied so that the box y does not fall due to gravity. The respective mass of x and y are 90 kilograms and 2 kilograms. And there's a frictionless horizontal force, okay, in between the two blocks. And between the two blocks, there's a coefficient of friction of 3/4, 0.75. Approximate the magnitude of the force. Okay, so again, force being applied horizontally, y is pressed against block x. So to keep block y from falling, friction must balance its weight. So that F sub s, that has to equal that mu n. And that's got to be greater than or equal to m sub yg. So the normal force comes from the horizontal acceleration. So n equals m sub ya. So if we calculate this, a is g over u. So we get 9.8 over 0.75. So the acceleration comes out to 13.1 meters per second squared. And if we take the total masses, mass of x, mass of y, those blocks respectively, we get 92 kilograms. And then we find the force is equal to the mass, total mass, times the acceleration. So it's going to be 92 times 13.1. We get about 1,200 newtons for the force. Okay, 46. A wire of diameter 0.08 meters contains 1 times 10 to the 26 free electrons per cubic meter. And electric current has 350 amperes. What is the drift velocity in the wire for the free electrons? So here's our drift velocity formula. I equals NQ AV, that's B. And here we have V sub D is equal to I over NQA. That's what we want to find. Our area, it's circular, it's pi r squared, so it's pi times 0.04 squared. In scientific notation, the area is about 5.0, I'm sorry, the A value, 5.03 times 10 to the negative 3 meters squared. That's our A. I should just say A for this situation. So V sub D, just substitute everything. Okay, so substituting everything, we just get V sub D equals 4.35 times 10 to the, that's a negative 3 meters per second. So that's our drift velocity. Might as well just keep it in terms of just what it says, A, instead of extending anything. The less syllables, the better if we could get through it quicker. And let's see here. 47, last three. In free space, the rocket's equation of motion can be represented by m dv dt plus mu dm dt equals 0. What do mv mu? This should be a mu. T, dv dt and dm dt represent each. My apologies for that. That should be a mu. So m equals the rocket's mass. V is the rocket's velocity. T equals time. Mu is where they're trying to trip people up on an exam, I guess. Mu is the exhaust velocity relative to the rocket. And then dv dt is the rocket's acceleration. And then dm dt is the rate of change of the rocket's mass. Okay, moving along. 48. In its rest system, a rod measures 5.25 meters. An observer traveling parallel to the rod must move how fast to measure the length of the rod to be 1.75 meters. This looks like special relativity problem. Length contraction, L equals L naught over gamma. Take what we're given with L naught and L. So L over L naught, that equals the square root of 1 minus V squared over C squared. We substitute. We do our algebra and arithmetic, and we wind up with V is approximately 0.43 C. Okay. And the last one for this set, what would be the product of sigma sub x, sigma sub z, if sigma sub x, sigma sub y, sigma sub z are Pauli spin matrices? So here's what we know from our Pauli spin matrices. Please forgive my poorly drawn delta. Okay. And just fast forwarding for sigma sub x, sigma sub c, z, that's going to equal negative I sigma sub y. So that required, knowledge of the Pauli matrices and relationships between those. All right, so that's 12 problems gone over rather quickly. Hopefully this batch of problems just, it's fun. Helps you just if you're getting ready for the GRE physics, just do as many practice problems as you can. These are rather canonical, similar to, but not the same as ones you'd see on a GRE exam. Okay, well, thank you very much and have a great day.